All right, welcome everybody to the very first ever Juju Charmer Summit. We're really excited for you to be here. I hope everyone had a good trip here. If you've parked locally, we've got travel vouchers. If you haven't gotten one, you should have received a t-shirt. What we're going to do here is we're going to go through and introduce ourselves and do all that stuff. But first, what we really wanted to do is ask Mark to kick off the summit, why we're here, why we're doing these things. And then we're going to get into how us at these little tables here can help you do fundamentally what you want to do, which is save your developers and ops people a bunch of time and money and do really great things. So first of all, thank you for coming. We really appreciate this. I know it took moving certain mountains for some of you to get here. So over the next 2 days, we're going to really work hard to make sure that you're getting the value out of this event. So after Mark is done, we'll do introductions, we'll go through the schedule a little bit, and we can kind of call an audible if necessary. So is everyone ready to go? Yeah. All right, excellent, awesome. All right, Mark, go ahead.
George, hello everybody. Nice to see you all there. Sorry I can't be with you in person. I'm reaching out to you from the Isle of Man on the other side of the Atlantic. But I'm delighted to be seeing everybody come together with the goal of turning the art of charming into something of shared science across community and commercial community members. So I want to start by showing you a view of software generally, and Antonio, if you want to bump onto the next slide, this is how we're thinking about software at scale as people move into the cloud. We think that there is a very clear imperative to move to a new level of automation, a new level of model-driven deployment for all software. But we think there's this clear divide between two kinds of software. And it may not be immediately obvious to people, so I want to kind of talk through it. Those two kinds of software are, on the one hand, shared, standardized software. And on the other hand, the private apps that power every business. And when you think about it, these are two very different beasts that behave in quite different ways. They obviously have things in common, and they obviously all have to be glued together. But as we go forward together, I really want you to think about this difference, the difference between the software that is common to many places, common to many institutions, common to many environments, and the software that's highly specialized and built essentially business by business, institution by institution, and deployment by deployment. So I'm going to refer to those generally as shared applications, applications that many institutions, many people reuse effectively. Often those are commercial, right? If you think about it, we all use pieces of software. If we buy the same piece of software, whether that's an SDN for OpenStack, whether that's a database, we're using exactly the same piece of software across many institutions. And we may use it in different permutations, configurations, and so on and so forth. We may stretch it and flex it, but it is fundamentally the same part that we are reusing. It's not strictly speaking true that they're always commercial. Shared software, for example, a lot of open source is shared software. But typically, this is software that is seldom modified. If you think of MySQL, for example, for every 1,000 deployments of MySQL, only one will use modified code for MySQL. So there's this tremendous commonality across all of the different places where that piece of software is being used. Increasingly, these shared apps are complex and at scale. If I think of all of the interesting software that's being written today, it is complex and at scale. I was part of a panel recently at the OpenStack Silicon Valley Forum, and there were a bunch of configuration management specialists on the panel. And somebody asked the question, why is it so hard to deploy OpenStack using the traditional tools, Chef, Puppet, and so on? And one of the founders of one of those tools said, well, this is because OpenStack is the most difficult piece of software that any company is ever going to deploy. And I take exactly the opposite view. I think OpenStack is just the first of the new generation, the new class of software. It's big, it's complex, it's multi-service, and it's distributed, and it's multi-host, right? All of the interesting things that I follow as new emerging technologies that are going to be amazing in our lifetimes, in our careers. Machine learning. Well, look at machine learning. It's big, it's complex, it's multi-service, it's distributed. Look at PaaS, right? All of the PaaSes, even the new emerging little Docker PaaSes, they're big, they're distributed, they're multi-service, they're multi-host. So OpenStack is really just a teaser trailer of what the new shared software world looks like. So a lot of these things are typically paid, supported pieces of software. Even if they're open source, they're paid and supported. And when you think about that software institutionally, you really want to think about efficiency. You're not innovating. If you use the Oracle database, you're not innovating. You're just doing the same thing that everybody else who's using that database is doing. If you use Apache Hadoop, you're not innovating. You're just reusing Apache Hadoop. So what you need to think about as an institution is efficiency. How can I most efficiently get all the value out of Apache Hadoop or OpenStack or Cloud Foundry or another of these large, interesting, complicated pieces of software? So in the shared apps column, we really optimize for efficiency. And examples, I've given some examples there. They're commercial pieces of software, and then Tomcat, MySQL, Postgres would be other examples. In the private app space, the picture is quite different. Private apps, the things that power a particular web page inside a particular bank, are almost always custom written for that institution. They're never going to be shared, they're never going to be reshared. The support model, the business model for those is typically they're free inside that institution, right? They're written for the institution and they're supported by the institution. And in that world, we tend to want to optimize for speed. We essentially say we want to cut as many corners as possible in order to go super fast to iterate that internally developed application. So why am I painting this picture of the two faces of enterprise software today? Well, I think it's important to understand, if we just jump to the next slide, because to my mind, charms are the approach that is going to give the maximum efficiency to the whole user base of software when that software intends to be heavily reused. So if you think about it, everybody who's deploying MySQL, everybody who's deploying OpenStack, everybody who's deploying Apache Hadoop, everybody who's deploying Cloud Foundry or Kubernetes or Mesos, anybody who's deploying a standardized complex topology wants to get the maximum efficiency out of that. And the way for them to do that is going to be to reuse as much of the intelligence that the community and charms are an extraordinary mechanism to capture that intelligence, to capture the operational dynamics of scaling out, scaling back, upgrading, updating, connecting, and dealing with dynamic events effectively. You can dramatically reduce your costs of operating a piece of software if you can trust a set of charms that will do most of the work for you. You can really reduce the skills you have to acquire, the time you have to spend, and the risks associated with essentially cobbling it together yourself if you can be part of a shared express train. And we've seen that pattern just with packaging in the rooms. We've seen that pattern very clearly, that people massively prefer the standard LTS package if it does what they need. They hugely prefer that to building their own tailored versions because they get updates, they get upgrades, they get the sense that they're on the same train as everybody else. What we want to do with charms is bring that to scale out, multi-node type pieces of software. By contrast, if you think of intensely private applications where you've really just got the shortest possible distance between the developer's laptop and the production system, then some of the tools that essentially allow you to clone the development environment and push it straight into production, some of those tools, the Docker-based tools like Swarm and Mesos and Lattice and Kubernetes, those tools are going to be super productive and efficient. And these are two halves of the same coin. They're going to work together really elegantly, really beautifully. Of course, it's not a simplistic picture. We will talk about using Docker as a way to deliver the application into a charm. So there'll be aspects in common across both of these halves. But I think if you see this picture and understand this picture, then you'll see that the charms that are going to be the most successful are the ones that really focus on stuff that's going to be most reused. Because the investment required to build a great charm means that it needs to be used as widely as possible so that it can be crowdsourced as efficiently as possible. So that's the sort of landscape of software. If we move on to the next slide, by and large, I'd say commercial applications are shared applications. Almost certainly, you want to, the commercial application, you want to be focused on efficiency. You can't typically modify the application. You carry all the costs of integration of that application. And so for both halves of that equation, the people selling the software and the people acquiring and integrating the software, that efficiency is absolutely key. But I don't think our story here is limited to commercial software. And so on the next slide, I want to make a point that most of the free scale-out components, whether that's Apache, Mongo, Tomcat, Cassandra, Nginx, Rabbit, those form a very large percentage of the actual workhorse backbone of many of these modern deployments, even of commercial software. And so I think it's really important that we have a free, open, crowdsourced collection of charms for that glue, for that backbone. And that's why Canonical has put so much effort into creating a set of end-to-end open source charms for these open source workloads, and why we appreciate so much the growing community momentum around those charms as people start to use them, scale them, exercise them, and then develop a wish list for them and start to carry carry those charms into more clouds and more environments. I think that's really important. So moving on. If I look at the IRC channel of the mailing list for a popular but new piece of software, it's full of people saying, how on earth do I get this thing stood up in this environment or in that cloud? And the developers of these really important pieces of community-driven software spend a tremendous amount of energy helping people do things that should just work, that should just be instantly, easily accessible to everybody, right? You want that piece of software on this cloud or that cloud, it should be instantly there. You want it on your laptop in many containers, it should be instantly there. You want it in highly available mode, you want it at scale. A key goal for us is to really help those communities by making it amazingly easy for people to spin up their software. And if I look at how quickly the Google guys asked us to bring the charms from Kubernetes into the Kubernetes tree, when they saw how easy it made it for them to get Kubernetes up and running on any cloud. There we go. So charming helps the community. And Tony, if you want to jump to the next slide. I think charming helps ISVs. I spend a lot of time with ISVs who are looking at cloud marketplaces, looking at being part of clouds, looking at analytics. And there are always the very large ISVs who have established sales channels, and they can take the time to essentially handhold customers through the processes that are required. But the guys who I think most are going to change the world are the rapidly evolving guys, the guys who are new and disruptive. And they don't have the time or the patience or the resources to go to every Fortune 500 organization and help them stand up the software. So we have this catch-22 situation. The interesting software is complex, multi-service, multi-host, hard to stand up and deliver. But that's where startups see most of their opportunities, right? So we have to figure out how to connect those dots. And as examples there, for example, I've been talking a lot with folks in the big data ecosystem. And almost universally, they suffer from the challenge of needing the underlying scale-out infrastructure to be up and running and manageable for an institution before their innovation can be evaluated or sold. So if you have a brilliant way to deal with large amounts of data, but you need Hadoop in base, you need Spark in base, your potential customers are taking a long time to figure out how to do that. That's a massive handbrake on innovation and on those ISVs. So charming, I think, is really important. It's really important for us to provide scaffolding so that those innovators can just plug in and show their stuff, whether it's on clouds or on-prem. And moving on to the next slide, I think charming ultimately most should help the developers, the ops, and the admins. I've seen within Canonical how our own thinking about our ability to spin our own infrastructure up on demand has evolved. Inevitably, in its lifespan, some piece of software has a major issue. And the question gets asked, why did it take us 6 hours to recover, to get back? And it turns out that the answer is to be deploying every day and timing the length of that deployment, right? It turns out that the answer is to take something that's hard and do it much more often, right? Which means in turn that you need to automate it. But more importantly, it turns out that you need choice, because if your region of Amazon goes down, you need to go to a different region. Or worse, if for some reason you need to go to a different cloud, potentially your entire tool chain may need to be adapted. So I see the encapsulation and modeling of software as vitally important for organizations as they move into this cloud era. I think the companies that have been born in cloud understand that. It's natural for them. They usually suffer from the fact that they're stuck on one cloud, the first cloud that they use, and for them the biggest priority is to figure out how to generalize their offering. For other institutions, the challenges are more complex. How do they support multiple clouds? How do they work across multiple clouds? There's another class of institution that I think is interesting that's kind of half ops and half ISV, and that's the SaaS vendors. If you want to be a SaaS vendor, you need to be able to operate your own software, and if you can only do that on one cloud, then you'll face ultimately competition from that one cloud. Whereas if you can operate across all clouds, you have a much more viable proposition. So it's really important for us to help the ISVs who are also SaaS vendors to be able to offer their solution in a highly automated, cost-effective way across all of those clouds. So that's why I think all of this is important. That's why I think this is possibly the most profound thing that's happening if I look across the cloud landscape, shift to model-driven deployment. And sometimes it's a little difficult to tease apart all of the different exciting things that are going on. But very consistently over the last 4 years, things have played out pretty much as we imagined they would. Highs and lows for Docker, highs and lows for all sorts of different ecosystems popping up and starting up. And yet, consistently, we've seen our ability, when we have charmed large-scale pieces of software, to go in and deliver that effectively in any cloud or in any physical environment, just get better and better and better, while many other folks seem to have jumped from one solution to the next. So I think this is how it's going to play out. I think we are going to see the emergence of that private app ecosystem, which is PaaS Lite, if you want to call it, and then we are going to see this model-driven, free and commercial ecosystem in the form of model-driven deployments, where charms essentially encapsulate intelligence and ecosystem. So moving on, the purpose, I think, of this summit is to reach out across the community of people who have eyes on charms and say, okay, how do we take this thing and turn it from an art, which is how I would describe charming today, it's a bit of an art, sometimes a black art. How do we turn it from that into science? How do we make it so that you're on rails when you are making charms? And how do we enable collaboration between people who are solving the same problems, right? And there has been some, I think, profoundly good work done, much of which will be visible to you today and tomorrow, and I hope to get to hear back at the end of the summit and see what guidance and ideas you have for how we can accelerate that. But jumping on to the next slide, the key things that I've seen happening are, first, the emergence of shared interface definitions. If I think of what it would take for me to write a charm that talks to, say, Hadoop and MySQL and something interesting like Keystone, right? I want to use Keystone authentication, but I want to integrate that with traditional and scale-out data. That's a really interesting proposition. Now I need to go and study the charm interfaces for all of those quite rich and complicated pieces of software. Well, what if I could just say, look, I want to make a charm that talks to that thing, and that thing, and automatically pull into my charm the state-of-the-art code in a format that can be essentially refreshed so that my charm becomes that I'm on rails effectively as I build my charm. And Marco and Antonio and the team, Ben and Co have done great work to make that possible. We've seen the impact of that in OpenStack, where we're working with lots of different vendors trying to help them integrate into OpenStack much more efficiently. They have to talk to many quite sophisticated pieces of software. And I think that is going to make a material difference to essentially put everybody on rails when you have a set of interfaces that lots of people need to implement and talk to. In terms of the charms themselves, I'm really interested in your feedback on some of the new capabilities, status and feedback. These are really important because they allow the charmer to take a view about when that service is, how well that service is running. You know, who else in the world could know as well as the charmer how to evaluate a particular service? If you think today, what a sysadmin has to do, they have to deploy the software, they have to study the software, and then they have to write the monitoring probes to tell them if that software is working. But what if that software just ran itself? And what if the software could physician heal myself and understand itself and provide much clearer feedback to all the other software in the topology? So that's what status and feedback is all about. We've seen some great results in the charms that I particularly care about, so I watch those very closely. And I'm very interested to see what a broader audience thinks of that work. Very importantly, the extending of the model to cover network and storage. Again, if I look at the really cool software, you always want to start having opinions about how it uses its storage. In a very simple example, you've got a database which wants different storage characteristics for its long-term persistent data store, for its journal, and for its logs, say. So that's one thing to be able to model in a charm. But then if you think of something like OpenStack, it is creating and using many virtual networks and virtual virtual disks. And if you look at a large OpenStack deployment, you can see an incredible profusion of these block devices and network interfaces and networks. Being able to create order and structure and insight in all of that is really important. If I look at a large scale-out NoSQL deployment, you could end up with hundreds of EBS volumes or Cinder block devices. You need to know what's in all of those things, which ones belong to which services, how to think about the lifecycle management, when you can get rid of them and which ones you need to look after. Providing the scaffolding to charmers to help operators do that is super exciting. Leader election, and we've had leader election a little while, but I think it's really coming into its own for people who are making HA charms. As charms are going into production, the ability to be highly available is super important. And actions, which are our ability to say, let's go beyond the base application deployment and lifecycle and look at the operations. How do I back that database up? How do I vacuum the tables? How do I pause a node in OpenStack so that no more guests get scheduled onto it so that I can do maintenance on it? All of those things are operational things that are hard to learn, expensive to learn if you're an institution, but they're shared. They're exactly the same operation for everybody. And so they're a perfect thing for us to encapsulate and crowdsource and share in a charm. So we're seeing this shift to go not just at the deployment of the software, the ability to spin it up and say, yeah, I can demo it, but actually to manage the lifecycle. So you take care of all of the data that piece of that application is generating or tending. You coordinate across all of the different units, and you manage the full lifecycle. There's lots more magic coming. We're very excited at the emergence of things like the Cloud Native Compute Foundation. People are starting to really think about the model of distributed software. And in Juju, we have a very beautiful, very elegant, tasteful, thoughtful structure for just that. I'm pretty sure that we can contribute thinking to that foundation and help people move along much faster. So just looking ahead, I want to give you a taste of things that I'm excited about in the roadmap. And if we can just bounce on to the next slide, please, Antonio. There we go. When I log on to a machine which is part of one of these big complex deployments, and I do a PS or a KVM listing, or use LexD to look at all of the different containers on the machine. It can be incredibly complex, right? I might have 50 containers, I might have 12 virtual machines, I might have a whole bunch of Docker processes all on that one machine. Each one of those things is there for a reason. But as an admin just connecting to that system, it can be difficult to sort of separate them all out and tease them out. Juju makes it incredibly easy to get all of that stuff up and running. We also need to make it easy for people to be able to look at all of these systems and catalog and understand all of those different moving parts. We have examples of folks who are using Juju's ability to spin up KVM instances, for example, inside the charm to charm up very old software which doesn't run on Linux. It runs on old operating systems, but it runs just fine in a virtual machine. We obviously see people interested in delivering their components as Docker images, and Juju provides them with a really nice way to build a reactive framework around that very static piece of Docker goodness, right? The reactive framework is what would deal with all of the dynamic scale and joining and unjoining and connection and disconnection type events that they will see over the life cycle of that piece of software. We're looking at resources, which are kind of a more general approach to having shared blobs delivered very efficiently to units. So, for example, think of everybody who needs a JVM or who needs 2 gigs of software delivered to the machine. Doing that in a really efficient way by having and being able to guarantee that you know which versions of that are on each of the units of a large scale-out deployment of WebSphere or MQ is really interesting, and that's what resources are all about. And metrics, which will let charmers who really understand the workload, who understand the software, start to express how that software is being used, how intensively it's being used, so that management and monitoring tools can have a consistent view across many, many different deployments of the pace and utilization of the scale and utilization of software, wherever it may be. So finally, if you just pop onto the next slide, I want to point out a couple of the key ecosystems that we see being critical for people who are plugging in and who want to be part of the next wave. Obviously, we see cloud, and the one cloud that everyone can agree that people should be able to deploy is OpenStack. Our charms really are the most pluggable way to integrate things with OpenStack, SDNs, hypervisors, storage and monitoring tools. Analytics and big data, both Hadoop and Spark, and the more general NoSQL movement, I think are again emerging as places where you see a lot of innovation from startups and ISVs, but they want to plug into an established, easy to spin up substrate effectively for the big data portions. And so we're very excited to be part of that. And then, of course, the other half of the software world, the sort of private app world, the container command and control world, are super interesting. Lots of innovation, lots of diversity, lots of fog of disruption effectively and all of that. And it's very nice for us to support that, enable people to spin all of those things up, evaluate them quickly, and then integrate them with some of the other software that falls into the shared app category and is much more widely reused. So that's all I had for you guys. I'm very happy to take questions, and we'll check in regularly with George, Antonio, Marco, and others to hear how things are going. Just thank you all for coming together, and enjoy DC.
Thank you.